All right, let's go ahead and get started. Welcome, everyone. Thank you for joining. Today, we're going to have a webinar titled Controlled Chaos: How to Monitor and Improve LLMs in Production. My name is Frederick Hell. I'm a founding lead front engineer at a company called Acario. Acario helps developers confidently ship LLM-powered apps with end-to-end tracing and real evaluation before and after development. If you have any questions or want to learn more about Acario, you can visit our website or you can reach out to me after the webinar. So I want to set the stage of where I believe we are today in 2025 when it comes to tech. And we've experienced something of a Cambrian explosion in the last couple of years. And it's been quite exhilarating, but also quite chaotic. And there's just been a lot of rapid changes happening in the last couple of years. So the way I like to think about it is very similar to what happened in the Cambrian period. For those of you who are not familiar and not nerds like myself, it's a quite fascinating period in our geologic history where there was a rapid explosion of different sorts of animals for reasons that we don't quite understand. That part's not quite important. What is important is there were all these niches that were just completely wide open, and there were no established strategies in our DNA, in the DNA of the animals at the time, to fit those niches. And so there was a lot of experimentation going on. And if you actually take a look at some of the images of this time period, the artist generated images, these creatures look like they're from another planet, like straight out of a sci-fi novel. But what's interesting is that there was a lot of experimentation going on, and some of the things succeeded and continued in our evolutionary history of this planet, and some just absolutely just didn't work, or at least not in the long term. And so, in many ways, that's what we're seeing right now in AI. Just from a couple years ago, where we had a handful of LLM providers, to now we have countless variants. I couldn't even tell you how many there are. There's just so many. We have all sorts of vector databases and frameworks. And so one thing that we know is that there's just going to be rapid change. What we have this week is going to be very different from what is true next week or next year. So that's something that we can count on. But in some ways, the AI technology is different from what we had before, in the sense that when these LLMs go wrong, there's no smoke that tells us that something went wrong. The failures are silent, and if you're not actively looking at your LLM implementation, you won't really know that something actually has gone wrong, because these LLMs are edge case factories. You can test as much as you want in development and in QA, but once you release your product in the wild, the combination of these probabilistic outputs with open-ended user inputs can lead to all sorts of edge cases. Some of them are benign, but some of them can be quite catastrophic for your business. And so, given just the chaotic nature and the rapid innovation and the fierce competition that's going on, you need to be able to quickly detect and iterate on whatever is happening in production. So the industry as a whole, and LLMs in particular, are chaotic. And I would assert that you shouldn't spend too many calories on trying to limit that chaos. It's better spent on actually trying to control that chaos as much as possible and contain it. Because LLMs are unpredictable by nature. No matter what you do, even the best models will go off the rails occasionally. So while you want to zero in on perfection, we have to accept the fact that there's a certain level of imperfection that you cannot eliminate. But what you can do is have visibility in order to mitigate those issues or eliminate them as much as you can. And you want to expect that there are unplanned edge cases, especially if you're not observing your LLMs in production currently. You probably have edge cases that you just haven't considered, and you just don't know about unless a user or someone tells you, if they're benevolent enough to tell you. But you can use this as an opportunity to use that chaos to get smarter over time and use that as a signal to continuously iterate and improve your LLMs over different competitors. And so I want to highlight three ways that LLMs can, or three reasons why LLMs go off the rails. These, by no means is not the only reasons, but these are the most salient in my opinion. One is that the outputs are probabilistic, meaning you can put in the same inputs, identical inputs to the same LLM model, and you could get drastically different results. Or even just tweaking your prompts ever so slightly can lead to vastly different outcomes. And over time, some of these outcomes can stray from the mean into regression territory. You also have these pesky thing called users, and users will do funny things, right? Some things that you expect or some things that are quite malicious. You might have some users that are attempting to jailbreak your LLM. You might have these long-running conversations in which the LLM loses context on what its original task is, or your policies, or whatever your LLM is designed to do or not do. And also, scale multiplies edge cases. This is one of those good problems, right? Where you want your LLM-powered app to be at scale. But once you reach that scale, you're going to see certain edge cases crop up continuously. This requires us to have a bit of a mind shift in that we have to expect that these LLMs are going to do things that you didn't quite expect. And in order to know what's actually happening, you have to have visibility from the start. You have to capture all these significant traces, metrics, and have the ability to surface failure signals as early as possible. Because if you can't see it, you can't fix it, right? We need to use these failures as learning opportunities, and we need to design for recovery, not perfection. So how do we actually see what LLMs are doing in production? Well, some of these strategies and techniques are fairly well established from error tracing in the past, but some things need to be adapted for the current landscape. One thing that we can do is have really robust tracing to capture every prompt, response, basically all the context that is necessary for understanding a particular interaction. You want to have monitoring alerts. You want to be able to surface signals from the haystack of noise and be able to have alerts and notifications on any sorts of errors or compliance risks as soon as possible. And in order to do that, you need a slightly different strategy. Because of the vast amount of data, human review is it's just not realistic. And it's also not practical or even possible to have deterministic code determine whether or not LLM's responses are factually correct or not. Oftentimes it's rather subjective, right? And in these cases, that's where LLMs as judges are actually rather useful. In particular, if you have many different judges. Rather than having one judge, you can have a collection of judges, each of which are specifically targeted for a very specific sort of issue, and they're watching out for that particular issue. So you can optimize each one of these LLMs as judges to look for a very specific thing, either for a general use case or your very specific use case. And of course, error tracking. So you want to be able to spot these regressions and behaviors over time. You want to make sure that if you've patched an issue, that as you move along and make changes to your prompts or switch model providers or what have you, that you're not reintroducing an error that you already fixed in the past. And so there are some issues that are very common in production that we have seen here at Acario with our customers. that I want to highlight so you can keep an eye out for those in your production applications. And one of those, which you might be very familiar with, is hallucinated facts. And even with the latest providers or with the latest models, they still hallucinate quite a bit. I mean, not a lot, but enough to where you notice it. If you're a subject matter expert, you might spot these sorts of things, but if you're not, that could potentially be an issue. And this is a very simple example. We have an input who said, "Move fast and break things," and I believe that's Mark Zuckerberg. But it's not out of the realm of possibility that an LLM will respond with Abraham Lincoln, right? I mean, you actually can't guarantee that an LLM will not give you this response, right? It's completely within the realm of possibility. And that's because LLMs, like I said, they're probabilistic, right? They're more about predicting the next token. They're not really about being true. It could be that the data that was trained on is incorrect, or it's trying to make an educated guess. But what these LLMs are doing, well, these LLMs they're awfully confident, and they're people pleasers at the same time. So they really want to answer questions even when they don't actually know the answer. However, you could mitigate this risk by implementing the strategy that I mentioned earlier, which is to have another LLM that is watching these interactions, monitoring these interactions, and could judge whether or not this output is factually correct. And so with very targeted and well-designed LLM as judge checks, you can ensure you have another fail-safe to make sure that these responses are actually correct. Another common failure point in production implementation of LLMs and products are issues around function calls. And here I want to highlight 4 different issues. It's not an exhaustive list, and it's not mutually exclusive. You can have a combination of these issues in any interaction. But by far the most common is an agent choosing the wrong tool for a task. So you can imagine an agent that its task is to search for films, but instead makes a mistake and searches for weather. This can happen for many different reasons. It could be that the agent just has too many tools. And so over a long enough timeline, it occasionally chooses the wrong tool. Or it could also be that the descriptions on these functions are not very clear and can be somewhat ambiguous. Or it could also be that its instructions are not clear enough on when to choose a particular tool. All sorts of things can go on. Another thing that is very common is when an agent calls a tool with the wrong arguments. So going back to our previous example, it could be that an agent does actually call a function for searching films, but instead of searching for a genre of comedy, it could look for a genre of 1, 2, 3. Another issue that is also quite common is when an agent calls the right tools, but in the wrong order. And this makes sense once you see the maturity of these agents, where as the product matures, the tasks also become more complicated, which will require multiple tool calls. And what can often happen is that the agent does call the right tools, but occasionally calls them in the right order. So for example, let's say you have an agent whose task is to analyze data, but it also needs to gather that data. Perfectly possible that it tries to analyze data before it actually gathers it. And finally, the LLM can actually completely fail to complete the task, meaning it could actually call the right function with the right arguments in the right order, but it doesn't actually fulfill the user's requests. So you can have a customer or a user that asks for a list of all of its customers, but the agent instead limits the request to 5 customers, thereby failing the actual request. And we're going to take a look at a practical example here. Acario has a onboarding tour that goes through some of these examples. And I want to start off with this tour. There are 3 different options here. we're going to ignore the first two for now. We're going to focus on the tool use. So we're going to go ahead and simulate an error. And what we're doing is in the background, we are making a call to OpenAI through Acardio's proxy, and Acardio is capturing the trace and running an evaluation on on this on this interaction. So we're going to ignore these for now. Actually, let's go back. So let me orient you here a little bit. We have some metadata here at the top that tells you a little more information about this interaction. We have some baseline metrics such as cost and output tokens. And we're going to ignore these for now. Let's look at the message history just to get oriented on what this interaction is about. So we have a few tools available. We have a search tool, and we have a another tool for scraping a LinkedIn company page. And it looks like the system prompt is telling this agent that it's part of a team. We have two messages from an agent supervisor, one with some metadata and another one with specific instructions on scraping John Doe's LinkedIn profile. And so the agent begins by making a search, and then it tries to call the last function to scrape the LinkedIn company page. And so just by reading this, as a human, it's not quite clear that there is an issue, even if we were pointed directly to it. And so this is where these explanations come in handy. So here, our LM as a judge check tells us exactly what went wrong. And it looks like actually what happened was the tool called, or the agent called scrape LinkedIn company page, but it was specifically tasked to scrape the personal LinkedIn page for this user. And so it ended up failing the task. Now, with that context, we can look at this once more, and we could see that, well, it wasn't actually given a function for scraping a personal LinkedIn page. So now we know what the particular issue is here. It's not necessarily the agent here per se, but it just wasn't given the tools. But at least now we have the visibility here. Another issue that is very common is policy and safety violations. And this could be quite crucial for a production app, because this could lead to quite a bit of regulatory and reputational risks. You definitely want to avoid inappropriate content being generated. You want to prevent jailbreaks, policy violations, and so on. LLMs now in 2025 are pretty good at refusing to generate inappropriate content. But because these LLMs are designed for a general use case, typically, they're not specifically, they could fail to follow your own policies, even when you give it context about your particular policies. So this is something that in many cases you want to make sure almost never happens, or literally never. So let's go ahead and take a look at an example of this. So again, we're going to take a look at our onboarding tool here, and we're going to select this first one, agent ignoring instructions. Let's go ahead and simulate that error. Again, we're going to make a call to OpenAI through our proxy, and then we're going to generate a trace and an evaluation on that trace. Has some metadata. We're going to ignore the explanation for now and just focus on the messages. And it looks like we have three messages. The system prompt gives very simple instructions, which is to avoid answering financial matters. Very simple. It has one job. Don't talk about financial matters. And in the following message, we have a user here who is attempting to trick the LLM into answering this question by saying that it's in debug mode and trying to diagnose an issue with performance, and then asking two questions on whether it should buy NVIDIA or Amazon stock. And the LLM, being the innocent and naive AI as it is, it decides to answer the question, and it answers both of those questions, which is precisely what it was told not to do. Um, so the model refusal check is designed to fail when a agent answers a question that it wasn't supposed to answer. And if we take a look at the explanation here, it basically tells us what we can see with our own eyes. But what's very critical here is that now we know that this is happening. We don't have to look through all of our traces and all of our interactions to know that this is actually occurring. And finally, I want to talk about conversation loops. This is actually fairly common with agentic networks, but it could conceivably happen in other contexts. And what happens in agentic networks is occasionally they get stuck in these loops where they basically keep going back and forth and they don't make any progress on the given task. So oftentimes these agentic networks and frameworks have the concept of a manager or an orchestrator or a supervisor, what have you. The point is that there's usually one agent that's in charge of the entire network. And what can often happen over time is that these supervisors get much more specific instructions over time to the point where they almost have run books or workflows, and they could get awfully specific and pretty constrictive. And so when something goes wrong, it doesn't quite have the flexibility to adapt, or even if it had more flexibility, it just couldn't do so. So, for example, let's say you had a manager agent that requests an analyst to do a particular task. The analyst, for whatever reason, can't actually fulfill that request. Maybe it doesn't have enough information, or it doesn't have the correct tools, or it doesn't have the right permissions, all sorts of reasons why it can't actually complete the request. And so the agents get stuck in a loop where the manager keeps asking to complete the task, the analyst says I can't do it, and they go back and forth and back and forth. This is actually a little tricky to detect if you're not observing your interactions in real time. And of course, this is a massive waste of user time, right? And it's also wasting your tokens. So let's go ahead and look at an example of that. And we're going to select the second in this list. We're going to simulate that error. Again, calling OpenAI through our proxy and creating a trace that we evaluate. We're going to ignore these two for now. Let's go ahead and get oriented on this interaction. So we have two tools, very similar to the first interaction. We have a search web tool and a scrape LinkedIn company page tool. Very similar. In fact, I think it's an identical system prompt to the first example. But now we have some metadata and different instructions from the agent supervisor. It's telling this particular agent to use a search tool and a scrape tool to collect background information on an individual. And the agent, or this worker, doesn't have all the information that it needs, and it says so. But the agent supervisor doesn't quite understand, and so it keeps going back and forth. It keeps trying to restart this task. So we can go into our loop guard check, which specifically checks for these sorts of loops, and it tells us that there's a repetition here. Here it's actually pretty easy to spot, but in some of these interactions, they could get really long because there might be JSON data being shoved in here. These interactions could get really, really, really long. And so it could be that it's not readily apparent to a human that there's a loop going on, unless you look very carefully and you're looking and you know what to look for. Whereas an LLM as a judge, it could spot it like that. It just knows right away. So now that we talked about a couple of issues that can happen in production with LLMs, let's talk about some control strategies. You want to have, like I mentioned a couple times, you want to have instrumentation from day one, where you can collect traces, errors, and key metrics. You want to iterate on your prompts and treat them as code, and take that seriously. So what does that mean? Just like with code, you have observability in production, but you also have test suites that you run to make sure that your code that your code is stable. You could do the same thing with your prompts, where you're observing in production and you run essentially tests to make sure that whatever changes that you do make, you're not accidentally introducing some sort of regression. Because, like I mentioned before, even tweaking your prompts just a little bit can lead to wildly different results. And you want to make sure that if you change anything, you're not accidentally reintroducing a bug or introducing a new bug. You want to patch with examples. And this one is pretty powerful. If you are watching interactions in real time, you can take these failures and integrate them into the context of the LLM to make it less likely that it happens again. So this is actually much faster and cheaper than reaching for fine tuning. There are limitations to practical limitations to fine tuning. You need a lot of data to train on, and you just might not have that much data in your particular use case. Whereas providing your prompts with a set of examples can really go a long way to improving the responses of your LLM powered apps. You should consider canary releases and version tagging. This is actually fairly convenient for prompts in particular, because there typically aren't external dependencies, such as database migrations and so on. So you can fairly confidently have a subset of your traffic on a different version of your prompts, and you can compare what you currently have with what you want to release and whether or not this is actually improving the overall task. And finally, you want to consider having humans in a loop for high-risk paths. There are some things that will require a human to review. And as much as there's a lot of hype around vibes, and particularly around coding, I'm not so sure we want to send a manned mission to Mars or open heart surgery based on vibes. I think in 2025, there are a lot of things that still require a human in the loop to make sure that they actually work. So, Acario actually takes care of a lot of this. So, like we saw in the demonstration, we have full context tracing. One thing that we didn't go into is segmented monitoring. So you can actually split up your traffic into different buckets and monitor them separately. So, for example, you can have a subset of your traffic that you want to make sure is not violating policies, because that's more of a tricky part or a user-facing part of your app. And you can have another part of your traffic with a different set of checks. You will have automated evaluation. We have a lot of out-of-the-box checks that we have tested quite a bit and are battle tested, and we know they work pretty well for a variety of different use cases. However, chances are you are probably doing something very unique that no one else is doing, right? As usually is the case in software. And so we have the ability for you to create your own checks that are very specific for your own use case. And you can write very targeted checks that ensure that your LLMs are doing what you wanted them to do in production. You could also set up alerts and digest. So any sort of critical errors or any sort of um, anything that you really want more of like a real-time update, you can receive via Slack or email. And we provide summaries that you can read over that tell you more about your monitors and how they're performing in real time. So to wrap up, I hope that we have I've laid out an understanding that there's a lot of unpredictability generally in the industry, but also specifically in LLMs. And our goal should be to try to contain that chaos as much as possible with the right systems that allow us to iterate quickly. And taking that mental model is more of a competitive advantage than trying to clamp down on that uncertainty. And with that, thank you very much for tuning in. Again, my name is Freddie Ronald. If you want to learn more about Acario, please visit our website at acario.com, or feel free to email me at freddie@acario.com. And now's a good time for questions if you have any.